Hey everyone, welcome back to my Calculus 2 series. In today's lesson, we're going to be talking about another technique for analyzing series convergence and divergence called comparison tests. The idea behind a comparison test is kind of obvious. What we want to do is we want to take the series that we're analyzing and we want to compare it to a series that is already known, or that we know whether it is convergent or divergent. So I'm going to go ahead and write out two of the main conclusions that we can come to if we were to use this test. Here are the two main conclusions that we can come to from comparison tests. And first of all, again, we suppose that there are these two series, and both the series have positive terms. So we say that if b of n right here is convergent, and every term b of n, for all n, meaning all terms in this series, the second one, are going to be greater than every term in a of n, then what we say is that a of n is also going to be convergent. Now, one of the ways we can think about this is that, let's say we have b of n, which is going to be this blue one right here, and then we have sort of a of n, which is smaller. There is no way b of n, this blue one, can be convergent if the series, in a sense, making it up, is going to be divergent. So there's no possible way that this larger series, which is made up of a bunch of smaller ones in a sense, is going to be convergent if all of a sudden one of those series making it up is going to be divergent. So that's basically what this first point is talking about, that if this larger series is convergent, then we can conclude that all of the series in a sense making it up or smaller than that series are also going to be convergent. Now for the second point, we say that if b of n is divergent and a of n is going to be larger than b of n for all n, meaning that now a of n is kind of the larger function if you want to think about it that way, then we say then a of n is also divergent. So again, now this is kind of the opposite case. So if we were to have b of n being this blue function and then a of n being this green function, well, a of n is larger than b of n, meaning the nth, any arbitrary point at a of n is going to be larger than b of n. We could see that, well, if b of n, this blue function right here, is divergent, then like I said, there's no way this top one is going to be convergent too, because the green function, in a sense, you can think of it as being made up of a bunch of these other series. So if the function making up the larger one or the smaller function is divergent, then for sure we can say that the larger function is also going to be divergent. Here's a quick example as to how we can apply what we just learned about those comparison tests. So we're given a series right here and we are asked to find whether it's convergent or divergent. So the way we go about using these comparison tests is we usually want to compare with the largest order of n from the numerator and the denominator. What that means is we look into the numerator and we find, well, what is the largest order of n? Or we want to find what is the most dominant term. You can think of it that way as well. So in this case, in the numerator, the most dominant term is the 5. And on the denominator side, well, the most dominant term is 2n squared. So this right here is going to be the series that we are going to be comparing this one to. So let's analyze the terms. First, we have this series that we started off with right here, and we want to compare it with 5 over 2n squared. Now, it's pretty obvious that this term is going to be larger than this one, because if we notice over here, we also have this extra kind of stuff tagged on to the end of it, meaning that the denominator of this term is going to get even larger as n increases, which means that the entire fraction is going to be getting divided by a number that is larger and larger. Therefore, we can say that this function right here is going to be larger than this one right here, again, because the denominator is going to be getting larger and larger, meaning the fraction itself is going to be getting smaller. Because we know that this one right here is going to be larger, well, now we have to go back and analyze this series. So 5 over 2n squared. What do we know about this series? Well, firstly, we can kind of move out these constants and get 1 over n squared. And now, if you remember, this is simply a p series with p equals 2. And if you remember, p equaling 2, that means that this series would be convergent. So again, that's simply because p is going to be greater than 1. And if you don't know this about the p-series yet, I suggest you go back and watch the past 2 lessons, because we go over the p-series and other common series in depth over there. So now again, because this function right here is the larger one and it is convergent, that would mean that all of the functions that are smaller than it, or all of the series that are in a sense smaller than it, are also going to be convergent, because the bigger function cannot be like composed of another series that is smaller than it but is divergent. So we know that through the comparison test, this one right here is also going to be convergent. So now moving on to the limit comparison test, and this one is a little bit different, but it kind of utilizes similar kind of concepts of like comparing one to another. So we suppose that we have these 2 series with positive terms. Then what we want to do is we want to divide the starting series by the second series in a sense, and we want to take the limit as that approaches infinity. And then if it approaches this constant c, well then and also this constant c has to be greater than 0. If that is the case, then we can conclude that either both of these series are convergent or both of them are divergent. What this would mean, if this right here is the case, well, that would mean that both of these series are kind of the same type, or like convergence and divergence, if that's how you want to think about it. So here is another example, and it asks us to determine whether this series is convergent or divergent. Again, we're going to start off by finding what is the dominant term in the numerator. Well, clearly it's this one right here. So what I'm going to do is I'm going to write this as the numerator of the second series, b of n. And then what is the dominant term in the denominator? Well, it's this n to the 5, however, it's with a square root, so it'll be n to the 5 over 2. And as you can see, we can simplify this a little bit to be 2 over n to the half. So this will be b of n. If we were to be using the regular comparison tests, we would need to know which function is greater than the other one and have some sort of like proof behind it, or some like logic, like before we could figure out, well, we had these like trailing terms in the denominator, which would be increasing the denominator, meaning the whole function would sort of be getting smaller and smaller. However, in this case, we don't really know how to compare this function to this one right here. It's a bit of a mess. So this is a pretty big giveaway that we are going to be using the limit comparison test. Now, what the limit comparison test tells us to do is we want to take the limit as n approaches infinity of a of n and divide it by b of n. So in this case, a of n is the series that we started off with, which is up here. So it's going to be, we want to take the limit as n approaches infinity of a of n. Well, a of n was 2n squared plus 3n over the square root of 5 plus n to the power of 5. And then we want to divide this by b of n, but I'm not going to divide in this case. I'm just going to multiply by the reciprocal of this. Essentially, it's going to be the same thing. It's just to kind of save space on the slide over here and not have some like layered division right here. So this is the same thing. Well, now we have this limit, and what I'm going to do is I'm going to multiply both of these terms inward, and then we're going to slowly solve this limit. So there we go. Now what I notice is that I can factor out this n to the 5, and I will be left with n to the 5 over 2 in the denominator. And if I factor out the same term, n to the power of 5 over 2 in the numerator, then I'll be able to cross these out. So I'm going to go ahead and factor them. So there we go. I have factored out those terms, and I've kind of shown my steps as to how I got there. Now we are left at this final step right here, and there's no more simplification to do. And as we can see, all of the terms are over this variable n, and since n is going to infinity, then these terms just lean towards 0. So basically all that we're going to be left with is it's going to be 2 plus 0 over 2 times 0 plus 1, which is going to be just 1. Now this is that c value that we get, and because, well, c is greater than 0, 1 is going to be greater than 0. In this case, what we know is that both of these series are going to be of the same type, meaning they're both convergent or they're both divergent. But the series that we were comparing it to, obviously we don't know anything about this one right here, because, well, we're trying to figure that out. So the only thing left to do is to work with this series right here. And what do we know about that series? Well, if we analyze it, it was the series of 2 over n to the 1/2. Well, what do we know about this series? This series is the equivalent of this, and this right here is a p-series with p equaling to 1/2, meaning p is not greater than 1. Therefore, this series is divergent. And because this series is divergent, and we know that through the limit comparison test, both series are of the same type, then we can conclude that the original series that we had, is also going to be divergent because of the limit comparison tests. So that's it for today's lesson on the comparison tests. Hopefully you guys have enjoyed the video and learned something. If this video has helped you out at all, please like and comment as to what I helped you out with. Like usual, if you're new to the channel, please like, comment, and subscribe. It's greatly appreciated. And yeah, I will catch you guys in another video.